Okay, here are the solutions to problems 5 through 8 for exam number 2, Engineering 1301.
Thank you.
Okay, here are the solutions to problems 5 through 8 for Engineering 1301, exam 2, fall 2018. Okay, so for problem number 5, you're supposed to know the sign convention, okay, and so what we see here is that current is moving in this direction, as indicated by the arrow, which is from minus to plus, so that's in the direction of a voltage rise. So this is the active sign convention. Okay, and so in this particular case, the power supplied, although I didn't ask that number, would be 20 watts supplied. Okay, next we have essentially a units problem, but also you need to know the relationship between energy and power. Okay, so we have an energy rate, which is power. We know we're starting with 470 watts that is transferring through the wall. All right, then we can convert that to total energy if we multiply by time. Okay, so we know that it's going to be, for a full day, 24 hours. Okay, and then we know that watts are in the units of joules per second. So we really need to convert this time parameter, hours, into seconds. And so we know that in 1 hour, there are 3,600 seconds. Okay, and so what that leaves us with is 4.06 times 10 to the 7th, and this would be watt seconds, which is the same thing as joules. All right, so there's the answer for problem number 6. Okay, problem number 7, also essentially a units problem. All right, so in this particular case, we have a light bulb. It's 13 watts. All right, so to go from watts to power to energy, you multiply by time. Okay, so we're curious about 30 days, and we know that in 1 day there's 24 hours, and we know that our answer that we're looking for is going to be in kilowatt hours. Okay, so then I know that there's 1,000 watts in 1 kilowatt. All right, so looking at the units, the days cancel. All right, we still have hours on the top, which is what we wanted. The watts cancel, and we're left with kilowatt hours. Okay, so when you move through this, do these calculations, you get 9.36 kilowatt hours. Okay, so kilowatt hours is a measurement of energy. That's what your electric bill comes in. Okay, so a typical apartment like you guys might be living in is probably looking at 1,000 to 2,000 kilowatt hours per month. So that gives you some idea. All right, the last one that I'm going to go over with this video, problem number 8. This is a differential temperature, so you can't just use the Celsius to Fahrenheit conversion. Okay, remember, if it's differential, that constant of 32 is going to be subtracted out essentially. And so we talked about this in class, that really what you need to do is start with 30 degrees Fahrenheit, and then we know that the degree size between Fahrenheit and Celsius follows the relationship that there's 9 degrees Fahrenheit for every 5 degrees Celsius. Okay, so that's the conversion on the degree size. All right, and so Fahrenheit cancels, and we're left with 150 divided by 9, which is 16.67 degrees C. Okay, so there's the solution to problems 5 through 8 on exam 2.